Hi, a ball bearing falling from rest at a height h above the horizontal surface rebounds to a height e square h where e is a constant and 0 less than e less than 1. If the ball bearing is released from rest at a height h above the surface, prove that the total distance traveled by the ball bearing before coming to rest is 1 plus e square over 1 minus e square, the whole lot times h. If h is equal to 10 centimeters and e is equal to 3 over 5, find how many times the ball bearing hits the surface before traveling a total distance of 20 centimeters from the instant of its release. Now then, for a question like this, let me just try and make you understand what's going on here. Suppose this is the building, again this is the ground, and the ball is at rest here. Now the ball is falling. It falls to the ground to a distance of h. Then we are told that the ball is rebounded. It rebounces, and it rebounces to a certain height h1, falls back the same height as it rebounded, h1 again. Then when the ball comes here, it rebounces, falls back down. Let's call this one h2, h2. Similarly, we have a situation here, h3, h3, until the ball is on the ground. Now we need to find we're told that the rebounding height is, it rebounces to e square h, okay, so h1. Now the ball falls. Let's try to find the total distance. The total distance is going to be h, the original distance, plus all these, plus 2h1, plus 2h2, plus 2h3, plus and so on. And what is h1? We're told is eh square, so that's going to be h plus 2e square h plus 2e. Remember, if this is n, this is going to be e to the power of 2nh. So 2 times 2 is then 4h plus 2e, right? 2 times, this is 1, 2, 3, 2 times 3 is 6, alright, h plus and so on. We can now factorize. Putting h outside, we're left with 1 plus the 2e square, alright, plus 2e power 4 plus 2e power 6 and so on. So h into 1 plus, I can put the 2e square outside and factorize and get 1 plus e square plus e power 4 plus e power 6 plus and so on. That's going to go back to this if you multiply. So therefore we have got an h into 1 plus 2e square. This whole thing here is an infinite geometric progression, which is basically a over 1 minus r. So that's going to be a over 1 minus r, where we know that a is equal to 1, I mean here, and then r is equal to e square, e square, e square, e square. So therefore we're saying that h times 1 plus, this is 1 times 2e square is 2e square divided by 1 minus e square. So this is going to go further to h into 1 minus e square, this times this, plus 2e square divided by 1 minus e square, which leads to, if you want, 1 plus e square divided by 1 minus e square, and the whole lot times h. That's the total distance traveled, and this has been shown. And here is the answer to the first part of the question. Now then, for the second part of the question, we are supposed to find the number of times that the ball bounces or hits the surface before it comes to rest. I mean, before it actually travels a distance of 20 centimeters. Okay, if we look at the geometric progression, we have this geometric progression in other words. So what we're saying then is that the total distance that it should travel as required in the question is total distance. Let me just write this down. The total distance is going to be 20 centimeters before it hits the surface. So, and then we before it travels, yeah, that's the sum. Okay, we are further given that h is equal to 10 and that e is equal to 3 over 5. So let us take our geometric progression. Here we have h plus 2e square h plus 2e power 4h plus 2e power 6h plus and so on. Okay, and we are supposed to say that this total distance is going to be equal to 20. Remember, h has been given as 10, so 10 plus 2 times 10 is 20 e square plus 20 e power 4 plus 20 e power 6 plus and so on 20 e power 2n. Alright, we did realize that this was what we came up with before, e power 2n. And all of that's going to be equal to 20. So if we rearrange, 20 minus 10 is 20, and then we've got 20, we factorize 20, we have e squared plus e power 4 plus e power 6 plus and so on e power 2n. And all of that's going to be equal to 0.5, 20 minus, that's going to be 10. 20 minus 10. So e power 2 plus e power 4 plus e power 6 plus is equal to 10 divided by 20 is now 0.5. And over here we can use the sum, okay, of the first n terms. So what we're going to say is that Sn is equal to a into 1 minus r power n divided by 1 minus r. So all of that then is basically, remember that now a is equal to e square and r is also equal to e square. So the a is e square into 1 minus r is e, okay, square to the power of n, and then divided by 1 minus e square. So if we do that, it's equal to 0.5. Now from here we can start rearranging. So we have 1 minus e power 2n is equal to 0.5 times 1 minus e square divided by e square. Remember that e is equal to 3 over 5. So rearranging again, if you substitute e is equal to 3.5 here, you should be able to come up with, hang on, just 0.5 into 1 minus e square divided by e square minus 1 is equal to e power 2n. And by using logarithms, okay, you should be able to get 2n ln 0.6, okay, is equal to ln 1 over 9. I mean, rearrange. I just want to make this video not too long, alright? And if we carry on further by using logarithms, we will end up with n being equal to ln 1 over 9 divided by ln 0.6 to the square. 0.6 is basically 3 over 5, and this is e square goes there. Yeah, so 0.6 square, and all of that divided by the 2 here. So n should be then 2.1506. And this should be the answer to the question. Okay. Nice question anyway. Take care.